Welcome to an edited version of our live stream that took place April 21st at 6 p.m. where we taught a little bit of the basics of modeling in Fusion 360. If you want to see that full unedited and unadulterated video, we've got the link in the card right up there. But we have a next live stream to continue this one on April 28th, this Wednesday at 5 p.m. Eastern. We hope to see you there. Enjoy the video. Let us know in the comments below what you'd like to see us design on the next live stream. And hey, get subscribed while you're down there and leave us a like. It helps the channel grow. Enjoy the video. Welcome. We're going to be doing some interesting stuff tonight. We're going to be learning all about Fusion 360. But before we do that, I want to start and try off in, let's see, probably Tinkercad first, because it is a little more simplistic. So let's start there. All right, so let's talk about 3D modeling because, well, it's not always that easy. So let's start with what we're doing today. We are doing a cane. This is my cane. For those that don't know, about a year ago, I suffered a life-changing injury where I herniated 2 discs in my back. And yes, he can still walk. It's not that bad. But you know what? It still kind of sucks. At 31 years old, I need a cane. So this thing's kind of boring. The original handle for it sucks something fierce. So I made one. This one is fully 3D printed. It looks crazy acid green in this because of all the extra lighting that we have. Because I'm not actually using a webcam, we are using a camcorder for all of this that gives me a clean output. This fits my hand perfectly. We're gonna have a video coming up on this for you shortly so you can see how I did it. But we're gonna be doing the rest of the cane. We're gonna start here in Tinkercad. And while we're at it, let's talk about softwares. Tinkercad, as you can see, we have some designs in it. Tinkercad is not bad, but it's also not great. It is very intuitive. And so both Fusion 360 and Tinkercad are both inside of the Autodesk family. So this is kind of the place where you would go to log in. Fusion 360 is $495 a year, unless you sign up for their hobbyist account, which is legally free, which is pretty cool. Tinkercad is completely free, and we can do a new design. So Tinkercad is very similar to what you would expect out of a Minecraft or, you know, a building game. We can throw a box, boom, have a box. And now you can say, okay, it can be whatever darn color you want. It can even be a hole. Let's not deal with that yet. We have a 10-step box. The more steps you have, the smoother it gets versus the less smooth. Now, this doesn't matter all that much in a square, or I guess that would be a cube, but it matters a lot in a sphere. So if we look, we can cut it way down and its faceting gets higher, or we can kick it all the way up. If you are designing in Tinkercad for the purposes of 3D printing, you want to make sure that your steps are as high as possible. When it comes to sizing on Tinkercad, we can come right here. So we can say, okay, we want the length instead of 20. We want to change it to, I don't know, 80. There we go. All right, so it did that move for us. So now we have a, what is this? A rectangular prism that is 20 by 20 by 80 long. We are able to design in here. So let's say we have this. We can grab ourselves a cylinder. It's a hole. And so that means the end part will now have that cylinder cut out of it. And see, this is, you know, relatively obvious. We can scribble. So we can do, you know, 3D. Oh, come on. M. Yeah. I'm going to say done. I'm going to use it. I was going to initially try to design this in Tinkercad, but I know it's going to be a nightmare. Tinkercad is not bad when you're starting, and you will find very quickly that, you know, let's say I want to have this hole specifically here, but I need to make this bigger. Is it possible to lock shapes? Yes. So we can lock shapes, but now I can't change this anymore. So to do that, I can unlock it, I can grab this. Let's say I want to take this and change it to 30. Well, now nothing is connected anymore. There's no way to kind of click things together in that method. Go to Autodesk.com, search for Fusion 360, grab yourself a free trial. You can then, after 30 days, sign up for the hobbyist account. The hobbyist account only allows you to have 10 open things at a time, but you can deactivate stuff and then reactivate it later, so it's not bad. And if you are a student or you are a teacher, of which I am a teacher as well, you are able to apply for an education license, which is the $495 a year license, but totally for free. So we have 2 licenses here at 3D Musketeers. I have one that I pay for that is strictly for making stuff for clients. And then we have one that I don't pay for, which is my education one, which is strictly for things like this, educating, or when we go and hang out at schools digitally, because safety, well, I'm able to use that one and not really mix between clients and not clients. This is Fusion 360. So let's take a look. We're gonna do a new design. The thing with Fusion 360 and all CAD packages is you have to think, instead of cubes and, you know, cones and roofs and whatever the heck they're calling this, a round roof, I guess that makes sense, half sphere, you can't think like this. It's really, really weird. And I will tell you, as someone that has learned, it's kind of bad. So CAD is a little bit different in that we have to look at doing things on a 2D surface and then extruding. It is weird, and I promise we're gonna get through this. We're gonna get through it together. What we're going to use today, we're gonna use the cane today. We're gonna need that. We're going to need some calipers. The cheapest ones you can find that are digital will likely be more than adequate. We are also going to need the hardware. I've chosen M3 hardware to do this because it is my preference of hardware. I have pounds of it. There are 2 different diameters of this cane because it can be extended or retracted to different levels. So we need to get that. And to do that, we're going to use our calipers and we're going to measure the diameter. You want to make sure that you do not measure on a curve. So what happens on these, they flatten it as they go to curve it. This is not mandrel bent. This is just a cheap bent piece of aluminum. So we need to grab it when it's not curved. So we can grab it here on this edge. And it is 22.15. So we're going to do probably 22, we'll do 22.15, and we're gonna talk about why that matters. So we go up here, we grab the circle, we do 22.15, we hit enter. Look at that, we have our first shape. Gotta love it. So that's the diameter of our cane. Now we need to decide how thick do we want everything else to be. So some things that I want to have on this cane, I want to minimally make sure that I can put 3D Musketeers between these bends here. Now there's some labels and garbage that have been there, but we've got from here to here, which is longer than my caliper. I have a little 6-inch caliper. It looks like, we're gonna call it 450, and I think I might give myself a little bit of extra room because we will have to account, yeah, actually 450. So our real distance is 350. Normally speaking, 3 millimeters, 1/8 of an inch, 6 millimeters, 1/4 of an inch. So let's do one that is 6 millimeters. And we could very simply grab another circle, click it, and drag it out. But then we'd have to do, okay, you know, 22.15 plus 6 millimeters. Grant. Yes, plus 6 millimeters. There you go, 28.15. Or, let me delete this. We can click this, we can hit the O key for offset, and then we can choose 6 millimeters. And here's why we're going to do that. Let's delete this. Because if we go back to this circle and we do 22.15 plus 6 millimeters, okay, let's say I change this dimension to 15. The outside doesn't change anymore. They're not stuck together. If we click this and we do an offset, we do a 6mm offset. It's effectively the same thing. But now if I change this to 15, that 6mm offset stays with it. That's the trick with CAD. It is about making sure that everything is stuck to itself. We have 3D Musketeers. Musketeers. 10 plus 2. That's 12 letters. We have 350mm. So let's do this interestingly. This is all we're going to do right now on this sketch. So we're going to finish the sketch. But Grant, all we have is this weird dot. Well, we're going to extrude it, and that is the E key. You can also come here to the extrude button there. We're going to extrude this 350mm. This is the amount of workspace that we have. So we have all of this. This is how big that we have to work with, okay? But I'm already seeing that we're going to run into some issues. So let's go back to our sketch here. And let's design it out. I want this to be 2 pieces so that we can use an Allen key to screw them together. That allows me to take pieces off, put pieces on, whatever we want to do, it allows me to easily do this. So we need to have provisions for it, which include some lines. So we're going to do some drawing. We're going to take a line, draw it to here, maybe to there, maybe to, I don't know, here. When we do things that don't have numbers attached to them, they turn blue. Ultimately, for CAD, your goal is to go to black. You want stuff to be black. That means it is perfectly and properly constrained. Now, I want this to be in the middle. How would we do that? Other than measuring, it's not that easy. So we can cheat in CAD. We can do L for line, which brings that up, and X. X means construction. And so instead of that solid line like you saw earlier, these are dotted. Escape to get out of the line tool. Make sure that you turn off construction. Dotted lines don't matter. They're there for referencing. We're going to go to create. We're going to create a point. We're going to drag it up until you see there was a triangle. See that triangle? That means it's a midpoint. Now, we're going to make sure that these two are equal. Making sure that they are is very important. We also want to make sure that they are tangential. It appears they already are, which is great. Actually, I'm going to cheat because I like this style and I want it to look identical. So we're going to use the mirror tool. We already have our object selected. We're going to select the line and boom, it's now mirrored. But if you notice, everything is still blue because we are missing one key feature. We got to do one more line here. And these are always good to have. If you start and just do an L of constructions, it's a pretty good thing to have. But now we just need to set our distance from the center. So to do that, we're going to use the key D for distance. We're going to click this line and this line. And now that will tell us how far away we are. I don't want it to be that far, so I'm thinking maybe 22? Maybe. Yeah, 22 might work. Let's try 22 for now. We're going to look at the... I want to know how big this is. It's going to yell at me. Oh, I guess it won't. I don't want this to be any longer than, let's say, 8 or 9 millimeters, because we want to be able to pass... You know, let's make it 10. What size did I just open? M3 by 10. We're going to make it so M3 by 10s fit, since I have 100 of them. We're going to do that. So we want to make this 10 millimeters. And so the trick there should be pretty simple. We can put a hole through it so that we can insert the bolt and it will sit reasonably flush. This should work. And now we're going to do another mirror because I don't want to do this again over here and I want it to be identical. This is where it starts to get cool. This is where CAD really comes into play. Okay, right? It's mirrored. But let's say, I really want that to be 11. You see how everything just updated? That is why CAD is amazing. I'm happy there. Let's finish the sketch. But wait a minute, Grant, the sketch is gone. No, it's not. It's here. But wait, we want this to be the same length. Now, we could hit E again for extrude and, click the extrude, and we could even cheat and click this top piece. But we don't need to do that. We can come back into the extrude down here. We can double click it. We can just add these to it. There you go. And see, here's where it gets even better. Let's say go back here and say, you know, I really only want it to be 3 millimeters thick. I can do that and everything else adjusts. This is still 22 millimeters away. So now we might want to change that. Let's go to 20 and see what that looks like. Yeah, I like that. I like that. All right, there you go. And because it's CAD, everything updated. Okay, there you go. And this is parametric is what we're working with. So we've got this, and now we want to cut it up into 12 sections. Because we have 12 letters. Well, 12 digits. Right? Is digits the right word? 12 thingies. That's the technical word in 3D Musketeers. So we got to cut it up into 12 pieces. So to do that, let's do a offset plane. And I wonder if we... Yeah, let's construct an offset plane. Let's grab up our calculator. It's going to be over here. Cool. 50 divided by 12. Nice. We're going to go 30 just because I'm lazy and I don't feel like typing all that crap in. So let's go back to here. It's going to be off of this surface and it's going to be 30 millimeters up. Okay, we're going to keep doing offset planes. We're going to offset them off of the offsets. We can cheat this. All right, we're going to modify. We're going to split the body. We're going to split the body there. I'm going to select this plane for the splitting tool. Boom. You know what I'm going to do? I'm going to come in here. This is piece 1. I'm just going to turn that one off. And we're going to pattern, rectangular pattern, the body. We're going to rectangular pattern the whole darn body. So what we're going to do is we're going to do everything that we need. And then we're going to rectangular pattern the body. And then we're going to go back and individually do... which I think we can do on one sketch, all the 3D Musketeer things. Maybe. We're going to find out together. All right. So I'm going to... and basically, this is your bar with all your information. So I can turn things on and off. If I want to get rid of that construction, I can. If I want to get rid of the sketch, I can. The sketch is probably superfluous at this point, so we're going to get rid of it. We don't really need the plane anymore. We need to know the distance here. So if you don't want to go back to your sketch to figure out your distances, you can just click on something. It'll be down here in this corner. It is 10 millimeters. So we are going to do an offset plane. We're going to do one. Oh, we don't need to do that because we can have a plane right through the center. And that's why it's always good to work off of your origin, because now I've got my plane. I can come in here. I'm going to split your body with that tool, which I guess I didn't need to do that construction. I could have just used the origin. That's going to give us 2 distinct bodies. Pretty cool. So we're going to call this the front. And we're going to call this the back. So now we need to, we're going to remove one of them because we need to get where all of our holes are going to be. Me, I like stainless steel hardware, so I'm going to do 2 on every one of them. But I can't just draw a circle. I need to do another sketch. We're going to hit P for project. This will give us the systems we have to work with. And for some reason, if you project more than one thing, it ignores the first thing you click. Don't ask me why. It's just the way Fusion does things. We're going to do an L and an X. That's going to give us a midpoint that we can work with. But now is when you need your calipers, because now we're going to start measuring things, because now it starts to matter. We have our M3 bolt. We're going to take some measurements. We have 2.92, give or take. I know you couldn't see that because there is so much lighting in front of me. It's 2.92. Here's the deal. Something you need to know about 3D printing. It is not perfect. So we're going to do a circle here. Oops, Grant. You got to get rid of construction. X, get rid of construction. we're gonna do a circle, but we're gonna do it, let's say, probably 3.5. That's gonna give us enough to make sure that this thing slides through without any issues, and that we could then support, that we don't have to support it when we're printing and deal with the fact the top's gonna sag a little bit. We also need to know how big the head of the screw is. So the head of the bolt, excuse me, is 5.42. So we're gonna do 5.75 for that. But again, we wanna make sure that we do it as an offset. 2.25 divided by 2. So we have this. We also now need to get our standard metric M3 nuts. We're gonna get some measurements from this lock nut. I might eventually have to modify it. I'll likely end up doing that off camera, but hey, is what it is. We wanna know some basic measurements from this. So I wanna get the flat to flat measurement. Okay, just like that. I wanna get the flat to flat measurement, which is 5.43. There are two different ways to do this. We're going to do a polygon, and I believe the one that we want is, let me verify. We want a circumscribed polygon, because that, yeah, it gives me flat to flat. So this is 5.43. We want to give it just a little bit. We want these to be pretty tight when they go in. So let's do, I don't know, 5.43. Let's go to 5.6 divided by 2. And I guess if I get rid of the millimeters, it works. All right, so we have that. Now we're going to make sure that we have our things that are parallel. We want to make sure that everything is horizontal and vertical. So we'll start with this. We'll make that horizontal. Okay. And again, we don't have any more constraints on this because, well, we don't know where we want these. So we can move the entire thing. We're going to do some more lines here. I'm going to do a line here. And a line there. We also want to make sure that the center of this is coincident with the center. That's a big deal. We want to make sure that our bolts are centered along the system. And, you know, I'm thinking that I made a mistake having this be horizontal, because it means they're relatively close to this edge. So let's get a measurement between that point and here. 1.229 millimeters. So yes, I did make a mistake. I want that to go away. Can we rotate this? No, you're not going to allow me to rotate. Well, oh well. 1.229 millimeters, it's probably okay. We're not going to put a bunch of torque on it. Because X gon' give it to you.